12 3 is over multiplying polynomials, so multiplying monomials times monomials, and binomials times monomials, and binomials and binomials, and trinomials. So it's all about how do you multiply these things. So let's start with just plain old monomials. If I have negative 5x squared, and I multiply it by another monomial, 4x cubed, I can multiply unlike terms. That's okay. I can't add them, but I can multiply them. So it's okay to multiply these. And you already learned earlier with 12(1 when we did exponents. If I was the reason why I can multiply these, I can show you that I can write this out, the extended form. X squared is just 2 x's multiplied together. X cubed is 3 x's multiplied all together. So if I look at it that way, then I can say, okay, well, think back to 12(1, negative 5 times negative 4, those are just regular numbers, so that makes negative 20. And then if I have 2 x's times another 3 x's, then I have 5 x's, so I can call that x to the 5th. So if you get confused, remember, you can write it out the long way. I can't add these, but I can multiply them. So here's another example for you to give it a shot on. What if you have more than one variable? So I have 7xy to the 4th times x cubed y squared. So think about that there's really a 1 right here, right? There's really an understood 1. So if I solve it the same way I solved A, when I took the negative 5 times the 4, I can think of that as 7 times 1. So I can say 7 times 1 is 7. The x from here, whoops, I meant to change color. The x from here and this x cubed, x times x cubed will be x to the 4th. Remember those product rules from 12(1. Go back and look back at 12(1. Remember I said you should probably make a card with all the rules on it. That might help. And then y to the 4th times y squared is y to the 6th. Again, if you get confused, you can always write it out the long way. 7x, y, and then there's another 3 x's and 2 y's. And so you can just look at them and count them up. Well, I have 7, and then I have x to the 4th and y to the 6th. It's not like you're going to want to always do it this way. That's why I'm showing you those shortcuts. But you can do it that way if you get stuck, or just for a while until your brain starts to make sense of it. Distributive property. We've talked a little bit about that. You should already be familiar with it, but what you shouldn't probably be familiar with is using it to multiply a monomial like 2 times a binomial like 3x plus 4. You know how if there's parentheses, you're supposed to do the parentheses first. That's the order of operations. Well, I can't do this. I can't add a 3x and a 4 because those aren't like terms. So that means the distributive property is going to help me get around that. The distributive property says that if you have a number multiplied by a binomial or any kind of polynomial, you can actually multiply them separately. So 2 times 3x makes 6x. And then 2 times 4 makes 8. So then my answer is 6x plus 8. Here's another one. Okay, so negative x is the same thing as negative 1x. Remember that underwear coefficient or that understood 1, that coefficient that's out there? So put a 1 there if you want to. You won't see the 1 in a textbook, but you can put a 1 there if it helps you think about it. So negative 1x times 3x, negative 1 times 3 makes negative 3. X times x makes x squared. Negative 1 times minus 6. So you can either think about this as multiplying a negative 1 times a positive 6 and subtracting in the middle. I think it's a lot easier if you think of these as those bubbles that I taught you. And remember, distributive property is a product. So if these two yellow bubbles were multiplying together, negative 1x times negative 6x, you will get a positive 6x. Now some people don't like that, so let me show you, actually let me show it on the next page. Let me show you the other way. That's just kind of a shortcut, and I don't want you memorizing things and not understanding why they're doing that. So let's not take the shortcut. Let's say, okay, negative x times 3x. So that's going to make negative 3x again, squared. Okay, ooh, that's ugly too. There. Then I'm going to go ahead and put the subtraction down here. So I brought that down. So I've already brought it down, so it's not up there anymore with the 6. So now negative x times 6 makes a negative 6x. So now to simplify this, you don't want to leave double signs in there. Subtracting a negative is the same as adding. We talked about that in section 12.2. So if I was to simplify this farther, it's 3x squared plus 6x. So some students like to do it this way, some students like to do it that way. It doesn't matter, whatever way works for you. More complex problems. If I have 9x times 2x squared minus 3. Again, I'm going to have to use distributive property. So I'm going to go 9x times 2x squared. And do the arrows. Use them if you're struggling with this. So 9 times 2 is 18. And if I have 1x and I multiply it times x squared, now I have 3 of them. So I have 18x cubed. And then 9x times the minus 3. So I have negative 27x. This, I can't go any farther. That's simplified because those are not like terms. There's no more multiplication left. It's only subtraction. Here's another problem. Sometimes you'll have a binomial first and then a monomial. Remember that multiplication is commutative, so I can flip this around and say x squared times 5x minus 8. I can do that. I don't have to. I can distribute from the front to the back, or from the back to the front. So I can go x squared times 5x cubed, x squared times, or you want to go minus first, or if you want to go times minus 8. It's whatever way you think about it. So negative 8x squared. I can't put these together because one's an x squared and one's an x cubed, so I can't subtract them. I'm finished. There's another problem. I think they called it C in your book. So again, I'm going to use the distributive property and distribute through. So negative 7 times 2x squared is negative 14x squared. Then negative 7 times negative 4x. This is where if you want to put minus the negative 28x, or if you just want to write plus 28x, it's your choice. But it's negative 7, either minus, then multiply by 4x, or just times the negative 4x, multiply by the negative 4x. And then the last one, negative 7 times 6, makes negative 42. And D, the more you do of them, the easier they get if you're struggling with this. Do a few, check. Do a few, check. Well, I guess you check anyway because you're on the, you should have your textbook on the online. If you're getting them wrong, make sure you're making sense of it. Put that wrong one into your notes with how to do it the right way. That's a great way to learn. Even if you never look at your notes again, just by you writing it down and seeing it, it's getting into your brain better. Okay, so distributive property, 4x cubed times x to the fourth. That goes back to those rules of exponents from chapter 12:1. That's 4x to the seventh. And then 4x cubed times 9x squared. That's 36x to the fifth. And 4x cubed times negative 8 is negative 32x cubed. Always look at your answer and see if there's any like terms, because sometimes there's like terms and you can combine. But I have an x to the seventh, x to the fifth, and x to the third, so I can't do anything. Now we'll go to some where there's more than one variable. So if I have 2xy times 7x squared y cubed minus 1, it's still a monomial times a binomial. You're still going to have to use your distributive property. You just have more than one variable, and that's okay. So 2xy times 7x squared y cubed. The numbers 2 times 7 make 14. If you look at the variables, x and x squared make x cubed, and y cubed make y to the fourth. Now you can multiply the first term times the last term. So 2 times negative 1 makes negative 2. And then there's no other variables to multiply with, so the originals just come along. And then you're finished. Here's another one. So again, distributive property. AB times a squared makes a cubed b. Cubed because you've got the first a times the a squared. Then AB times the minus b squared makes negative a b cubed. And to the last section, multiplying binomials, or we even go into trinomials as it goes along. This is probably one of the more important concepts in algebra. If you have x plus 4 and x plus 2, there's a couple different ways to do this. The book does shows it geometrically, so it shows it as an area model, and then it also shows it algebraically. Algebraically is going to be the way that you want to switch to, but I will follow through, show it as geometric, and you can look in the book if you want to see more on that. But algebraically, you'll get there faster. But the geometric part of it might help you make sense of it. If you have a square and you call it, you say the length is x. Here's the square that makes x squared. So if I say I have x plus 4, this is what it would look like. I have 4 little marks there. And x plus 2 would look like that. If I continue to fill this in, and I make a square, I can see that I have an x squared. The area of this first box is x squared, so I have x squared. These strips right here, the length of them is x, and the width of them is 1. So I have 2 of them. Their lengths of, or the area of them is x. And then I have 4 more of them here. So I have, I have 6 bars that have an area of x. Then I have all these little pieces up at the top here, and I have 8 of those, and those are just single boxes that are 1 by 1, so the area of them is 1, so I have 8. So the area model of multiplying x plus 4 times x plus 2 would look like this, and the answer is here. I probably don't do a great job of explaining that. If you want to watch them, I would definitely go to YouTube because there's some really good videos on how to do that area model. It's hard if I don't have the little manipulatives to move around and show you and have more time to show you. But definitely if you're interested in that, it is a really good way to look at it, but I'm not doing a very good job of doing it on this whiteboard. So the algebraic model. I don't know if you've heard of FOIL. We used to call it FOIL when we were kids. But if you're going to multiply x plus 4 times x plus 2, you are taking x and you're multiplying it. Whoops. Hold on, let me get my pen here. You're multiplying x times this x, and then you're also multiplying it times a 2. Because you can't just multiply x. You can't add any of these. These are unlike terms. So it's like you're taking the distributive property and you're distributing each monomial within the binomial. So x times x makes x squared, and x times 2 makes 2x. So those 2 yellow stripes that I made, if I was to multiply those, if I was to distribute the x through the second binomial, I would get x squared plus 2. If I was to take the 4 and do the same thing, I have 4 times x, which is 4x, positive 4x, and I have 4 times 2, which is 8. So if I look at what I have now, I have 4 terms, and the 2 and the 8 are like terms, so I can put them together, and I can say I have x squared plus 4x plus 10. This video is covering section 12.3. It's on multiplying polynomials. If you have a negative 5 x squared and you multiply it times 4 x cubed, if you're multiplying things, you can multiply them in any order you'd like. So really this is the same as saying negative 5 times 4 times x squared times x cubed. So you can reorder it as long as there's multiplication between everything. That's the commutative property. So I can multiply the negative 5 and the 4 together and make that negative 20. I know from previous sections that x squared means that there's 2 x's and x cubed means that there's 3. So altogether there's 5, and I could represent that with an exponent. So negative 20 x to the 5th power would be simplified. The next example in the book is 7x y to the 4th. See if I can fit this in here. And x cubed y squared. Again, we can pull this all apart just because there is multiplication between everything. What's really sitting right here is the whole number 1, if you want to think about that. That's that coefficient. In previous tapes I called it the underwear coefficient. So I can take that 7 and multiply it by that understood 1, and that gives me 7. My x's, I have 1 x here, and I have 3 of them here because it's x cubed. So x times x cubed makes x to the 4th power, because remember there's that 1 right there, that understood exponent. And then my y variables, I have y to the fourth and y squared. So that simplifies to y to the 6th power. That's that product rule. That's as simplified as that gets. The next section is using distributive property, and I'm sure you've heard of the distributive property before in previous math classes. If I have 2 times the quantity 3x plus 4, 3x plus 4 is in parentheses, and normally, with the order of operations, I would have to do what's in the parentheses first, but I really can't do that because 3x and 4 aren't like terms, and you can't add unlike terms. But I can still multiply 2 through it by using the distributive property. So the distributive property kind of gets around that whole order of operations of you have to do the parentheses first. If I know that it's going to be 2 times the quantity 3x plus 4, I know that it's multiplication because there's nothing right in between here. So that's an automatic multiplication sign. I can separate them and multiply them separately. So 2 times 3x makes 6x. Because I can multiply unlike terms, I just can't add and subtract them. And then I can take the 2 and then distribute it to the second term. That's why it's called distributive property. And that second term then would be plus 2 times 4. So that would be plus 8. So 2 times the quantity 3x plus 4 simplifies to 6x plus 8. The blue arrow, that second distributive, that's usually where people will get stuck when they first are using the distributive property. So if you're looking in the back of the, or if you're looking at the answers, I guess you wouldn't be looking in the back of the book, you'd be looking on your textbook online, and you're getting them wrong, a lot of times that's the issue. So keep an eye out for that and look for that. The next example is negative x times 3x minus 6. And again, I can use the distributive property. The negative x, there's really an understood 1 there. That coefficient, that leading coefficient, is really a negative 1. It might help to draw that in there. So feel free to do that. In the textbooks they won't have a 1 in there, they'll just have negative x, but it's okay to put that negative 1 in there if that helps you think about it. So negative 1 times 3x. So I have negative 1x times 3x. So I know that's going to make negative 3x squared. I then have negative 1 times, you can either say minus times 6, you can subtract it and then multiply it by 6, or you can think of that as a negative 6. I'll show you both ways. Usually what I do is I think of this as one term and it's multiplying through, and negative 6 is the term. We learned last section that the negative goes with that 6. So I think about those bubbles multiplying times each other. So if I have negative 1x times negative 6x, then I have a positive 6x squared. Now let me go back and explain how you can think of that as a 6 also. Some people like to do it this way. Let me erase this. Some people like to bring this sign down and say that this is negative 1x times 6. They don't think of that as a negative 6. Negative 1x times 6 makes negative 6x. And subtracting a negative is the same as just plain old adding. So to simplify it all the way, you would need to write it as 3x squared plus 6x, which is the answer that I had before. I think it's just a little bit simpler or easier to not get so confused if you have an issue with signs, to think of those as bubbles multiplying together. Taking this idea a little bit further, multiplying a monomial times a polynomial. So again, I'll take the examples out of the book. If I have 9x times 2x squared minus 3. I'm still using the distributive property because you can see inside here this is 2x squared minus 3, and those are unlike terms. So again, unlike terms, I can't subtract those two, so I have to use the distributive property. So 9x times 2x squared, that's going to be 18x cubed, because there's really a 1 right there. And then the 9x, and I'm going to take this as a negative 3. And 9x times negative 3 makes negative 27x. You can see that the negative and the minus, I keep interchanging those. And that's my final answer. The next problem, (5x minus 8 times x squared). It's okay that the monomial is behind the binomial. That doesn't matter. You know, there's multiplication between these right here like we talked about, and so you can change the order if you want, as long as you leave 5x minus 8 in that order. So you could rewrite it like this if you want to, if that makes you feel more comfortable. But you don't have to. I'm not going to solve it that way. So I'm still going to distribute through. Doesn't matter which order you do it in. I have 5x times x squared. That's going to give me 5x cubed. Remember, because this is a 1 right there. And then I have x squared times negative 8. So x squared times negative 8. So negative 8x squared. If you distributed this one first and then this one, your answer would be negative 8x squared plus 5x cubed. So both of these answers are correct. Notice that the negative 8x squared is the same in both. So the signs go with those numbers. And, oops, let's see. C is negative 7 times 2x squared minus 4x plus 6. So we're dealing with a trinomial this time. So it's the same idea no matter if it's a binomial or a trinomial. I still have this negative 7 that I have to distribute through. So I'm going to start skipping that middle step. I'm going to start multiplying these together and just writing it down. So negative 7 times 2x squared is negative 14. Whoops. That's what I get for skipping a problem. First step. Negative 14x squared. I'm changing colors hoping that will help you understand where these numbers are coming from. So again, don't forget that that goes together. It might help you to bubble all of them and then just think of it as bubbles. So negative 7 times negative 4x makes a positive 28x. And then the last one, negative 7 times 6 is negative 42. And so you can see now that we have an x squared, we have an x, and we have a number without the variable, and so they're all different. So nothing's alike, so we know that we're done. Always check, because some problems you'll end up using the distributive property, and then there'll be like terms at the end that you need to then combine. So you just want to always look for that. Okay, so again, we're going to distribute. So I have 4x cubed times x to the 4th. That's 4x to the 7th. I have 4x cubed times 9x squared, so that's plus 36x to the 5th. And the last one, 4x cubed times negative 8. And so that's negative 32x cubed. And we're finished because all of them are unlike. Then the book gets a little bit harder in that it starts to give you a monomial that has two variables in it. So let's take this monomial 2xy times this binomial, 7x squared y cubed minus 1. So again, same idea. We're just multiplying together. Now remember, these whole numbers can be multiplied together. So 2 times 7 makes the 14. And then the x's can be multiplied together. X times x squared is x cubed. And the y's can be multiplied together. Y times y cubed is y to the 4th. And then 2x y times negative 1. So 2 times negative 1 makes negative 2. And then you still have that x and y. So there's your final answer. And the next one, negative ab times a squared minus b squared. Remember that this is a 1 out here. That will help you. So I have negative 1ab times a squared. That makes negative 1a cubed b. I don't need the 1, but I do need the negative. And then also there's a negative 1 right there. So negative 1 times negative 1 makes positive 1. I have an a, and then I have b cubed because of the b and the b squared. You can write your answer in that form, or this is fine too. This is more like what you'll see in a textbook, as they won't write the understood one. The next section is multiplying binomials. This becomes a big part of algebra, and so you want to make sure that you spend some serious time on this. If you can get the binomials times another binomial down, it'll make the rest of the year easier for you. They show it geometrically in the book, in the textbook, and they show like a picture that looks, I can't even do it. But if I were you, I wouldn't do a very good job of explaining it on the whiteboard here to show this. So if I were you, I would get on YouTube and watch a video. There's quite a few videos out there where they use these little algebra tiles, and they show you what x plus 4 times the quantity x plus 2 is, and they show you visually. The visual part is great for an understanding, but you're going to want to move to the algebraic part eventually, because the visual part would get too cumbersome and too slow. So go ahead and watch that if you're interested in that. But now that we have a binomial times a binomial, it's x plus 4 that's being multiplied times x plus 2. So it's not just the x, but it's x plus 4. And so what we do is we take it one at a time. So the x has to, whoops, lost my color there. The x has to multiply times the first number in the second binomial. So x times x makes x squared. And I'm going to change colors on you here to show this. And then it's also going to multiply times the second one. So x times 2 makes 2x. Then you're done with this first term, this x. You have distributed through the second binomial. So you're finished with that one. Then you go to the 4 and you do the same thing. So the 4 has to multiply times the first term in the second binomial. So 4 times x is going to be 4x. And then 4 times 2, which is going to be 8. So when you have a binomial times another binomial, you should always have 4 terms when you get done. If you don't, something went wrong. Okay? So after those 4 terms, you need to look at that and say, well, can I put anything together? Is there anything that's alike? 2x and 4x are like terms because they both end in x. They both have x as a variable. and the exponents are the same. So I can put them together. So I have x squared plus 6x, because the 2 plus 4 is 6, plus 8. So this right here is my simplified answer from my binomial times my binomial. It takes a little while for these. If you've never done this before, really spend some time doing a bunch of them over and over and over. Once you get the hang of it, they go pretty fast, and it will totally be worth it in the long run for you. The next problem is 3x plus 2 and x plus 1. I should probably tell you too, if you have an older brother or sister helping you or a parent, they might refer to it as FOIL. We learned it as FOIL when we were kids, that you multiply the first term, then the inner term, and the outer term, and the last term, and your book explains that. But you really don't have to go in any order. It could be FOIL, it could be LOI. It doesn't really matter. And so I usually just don't go by FOIL. I just say start with the first term, distribute it through. So 3x times x is 3x squared, and then 3x times 1 is 3x. Should have changed colors there. I'll just do it for the next one. And then the 3x is finished. Now you need to finish the 2, and you need to distribute it through. So 2 times x is 2x, and 2 times 1 is 2. And again, you can see that these middle terms then combine. So 3x squared plus 5x plus 2. And that's my final answer. You want to make sure that when you're going through these assignments too, that you are showing your work, because they do give you partial credit on the final test for that, if the work is correct, even if the answer is wrong. And we'll talk about that as we get farther in to the course. So the next one, and again, I'm just going to quickly go through this one so that you have the work. So 1 times 1 is 1. And 1 times 2x is positive 2x. And negative x times 1, make sure you see that as a negative, is negative 1x. And negative x times 2 is negative x times 2x is negative 2x squared. Then these two combine. So you have 1, and positive 2x minus 1x is a positive 1x, and minus 2x squared. Usually they'll turn this around so that the x squared is first. So if I did that, it would be negative 2x squared, and then the x next, and then the 1. But this is fine too, so either one. They usually put it in descending order. And the last one in that section is 4x minus 3 times x squared minus 2x. You might try this one on your own and hit pause, try this one on your own, and then look to see if you could get it right. So 4x times x squared is 4x cubed. 4x times negative 2x is negative 8x squared. Negative 3 times x squared is negative 3x squared. And negative 3 times negative 2x is positive 6x. I can put these together. So 4x cubed, a negative 8x squared, and a negative 3x squared is a negative 11x squared. Remember, those signs get tricky. And that's my final answer. Little bit tougher. What if you have a binomial, and it's not times a binomial, but it's times multiplied by a trinomial? It is the same idea. So this 2x, I'm going to start with that, and I'm going to multiply it, or I'm going to distribute it through here before I move to the 3. Okay, so 2x, whoops, So 2x times x squared is 2x cubed. 2x times x is 2x squared. And 2x times negative 1 is negative 2x. Then I'm going to take the 3 and do the same thing. So 3 times x squared, should have wrote smaller, is 3x squared. 3 times x is 3x, and 3 times negative 1 is negative 3. Now I'm going to combine like terms. So I have a 2x squared here, and a 3x squared. And I have a negative 2x and a 3x. So I have 2x cubed, and then the x squares together makes 5x squared. Remember, the exponents stay the same. And negative 2x and a positive 3x make a positive x minus 3. And we're finished. Notice that this was a binomial times a trinomial, and notice how many terms I had when I first multiplied it all out. 1, 2, 3, 4, 5, 6. And that's because this is a binomial times a trinomial, so 2 times 3 is 6. The next example and I'll quickly walk through this one, but you might want to try it on your own and pause it, try it on your own. So that's going to give me a cubed, then a squared b, and a b squared. It doesn't matter if you say b before the a or the a before the b. Usually the general rule is to do it alphabetically. So when I'm multiplying this b through, I need to remember that it's a negative b. So negative b times a squared makes a negative a squared b. Again, you could write it negative ba squared. Negative b times ab makes a negative ab squared. And negative b times b squared makes a negative b cubed. So if I look at like terms, ooh, this gets sticky if you have any kind of dyslexia or anything. A squared b squared, a squared b squared, and then ab squared and ab squared. So if I put that all together, I have a cubed. These two actually cancel themselves out because one's positive a squared b and one's negative a squared b. And then these two actually cancel themselves out too. So I get a cubed, b cubed. I can't put those two, I can't subtract those two because they are unlike terms. And then the last one is x to the 4th plus 2x squared minus 5 times x squared plus 1. If you don't like it with the trinomial first, usually what I will do is I will write the smaller one first. It's just kind of creature of habit. It doesn't matter because the reason why is because there's multiplication between there, and multiplication is commutative, so you can do it either way. So I'm going to solve it that way. So x squared times x to the 4th makes x to the 6th. X squared times 2x squared makes 2x to the 4th. X squared times negative 5 makes negative 5x squared. And then 1 times x to the 4th, and 1 times 2x squared, and 1 times negative 5. And then I'm going to put all my like terms together. So I have x to the 6th. I have 2x to the 4th, and x to the 4th. So that makes 3x to the 4th. The reason why it's 3 is, remember, there's an understood 1 right there. And then I have 5x squared and 2x squared, but it's a negative 5x squared. So it makes negative 3x squared and minus 5. And there's my final answer. The very last section Oh, the book also talks about how you can multiply and you can multiply vertically. You can look at that. I don't usually do it that way, but it is definitely a valid way. So you're welcome to look at that at the textbook. If you have a hard time understanding it, just send me an email or something, and I can put together a little video for it. But it's definitely a way you can do it. Some people prefer to do it that way. The last part is a little bit of geometry. You have a 3D figure, and that 3D figure has the length of h minus 3, or the width, the length of h plus 4, and the height of h. And it asks you to write a polynomial to represent the volume. Remember that volume is length times width times height. So I would take the height times the width times the length. Now I've got three different, two binomials and a monomial to multiply. It doesn't matter which one I do first. I'm going to go ahead and multiply these two together first, but I could multiply the other two, it wouldn't matter. So h times h makes h squared, and h times negative 3 makes negative 3h. Ooh, that looks like a b. I'm going to leave that in parentheses, because now I need to multiply it times the h plus 4. So I have h cubed plus 4h squared, h squared, minus 3h squared, minus 12h. So I have h cubed, these two go together, we make an h squared minus 12h. So there's my final answer. And then also in the book it tells you at the end, what if h was 10, then what would the volume be? Now you can sure plug it into all this picture, but what they're wanting you to do is to understand that you can plug it into your new formula that you made. So if you plugged it into your new formula, if you plug it into your new formula, you have 10 cubed plus 10 squared minus 12 times 10. So you have 1,000 plus 100. Because remember, that's 10 times 10 times 10 for the 10 cubed and 10 times 10 for the 10 squared. Minus 120, which is the 12 times 10. So 1,000 plus 100 makes 1,100. Minus 120 makes 980. So if it was feet or inches, you'd say, inches cubed or feet cubed or units cubed. So you can use your new formula. And that's it for section 12.3.